Hey everybody, let's look at this one with the peach can up here. So it says we got a 0.75 kilogram peach can is at rest in a shopping cart on the top of the hill. So it gets set into motion going down a 6.32 or 0.32 meter hill. Then it hits a stump and it keeps flying, and it hits a car where it exerts an average force of 721 newtons there until it comes to a rest. So several things they want us to fill out. First off is, what is the potential energy of the peach can up top? Well, to solve that, we'll do gravitational potential energy is mass times gravity times height. Plugging in for that, the mass is 0.75 kilograms, gravity is 10 meters per second squared, the height is 6.32 meters there, and multiply all those out and you should get 47.4 joules of potential energy. Now all of that potential energy is going to convert into kinetic at the bottom, so at the bottom we've got 47.4 joules of kinetic energy. But then the can comes to a rest, so we took all of that away. So we can also think about it that we had to do work to do that. So the work we do is equal to the change in kinetic energy. We know how much our kinetic energy changed. We lost 47.4. So negative 47.4 joules is the change in kinetic energy, which means that's also equal to the work. Now work is force times distance times the cosine of the angle between the two. So the force they gave us right here, it's 721 newtons. So 721 newtons times the distance is what we're looking for. This angle here, cosine of 180 degrees, because the can will move this way and the force will be back that way. So that cosine of 180 degrees, that just becomes a -1, which by the way will cancel out with this negative right here, so you could really just get rid of those two negatives. So to solve for the distance then, you just take 47.4 joules of work divided by 721 newtons of force, and you should get about 0.0657, wherever you want to stop, meters is how far the can moved into the side of the car.